All right, let's get started with the BrainX Community January 2025 event, and we have a very exciting event. Last year, 2024, the kickoff event was themed around strategies for AI and healthcare, because there was so much excitement about all these large language models, all the new AI tools, all the frameworks that were there, and we were all very passionate about using them. So we are thinking about like what are the strategies that we should be using. So we had a CIO panel, a featured CIO panel, which was essentially talking about the different strategies for AI in healthcare. This year, I thought that one of the very important aspects and the lessons that we learned from last year's key publications was somewhere around evaluation of these AI models that had been coming over, and some remarkable work that has been done. I'll invite the speakers and profile them shortly, and we'll talk about it. But I thought that's the perfect theme because all these large language models are coming. I know everybody is thinking about DeepSeek that plunged the stock market in many ways. So pretty significant impact. But how are we going to be evaluating? I think that's one growing theme, and I think that's why it was important for us to focus on that for this year. So thank you for joining us. For many of you who are joining us for the first time, BrainX Community is a platform that we created more than 6+ years ago. Very successful in that time period. We have more than 6,000 members, international community. We have a LinkedIn group, which is very, very active. So if you're not on that, please go to LinkedIn and join the group by the name of BrainX Community. We share a lot of scholarly activity, a lot of information related to AI and healthcare over there that you can get on your fingertips. Of course, we have our repository, our website. I'll briefly go through that so that you can access all the content that you want for AI and healthcare in one place. And then we do these monthly sessions to highlight some of the amazing work that you all are doing that we all can learn from, where we can have an exchange of information and dialogue too about the learnings that can be shared. So the website is brainxai.org. If you go over there, we have the landing page. You will get all the information about the upcoming events, any recent publications, books, podcasts that we feature over there. Of course, we have our Connect segment, which features our monthly sessions, the live sessions like we have going on right now. So even if you miss, you can go to our YouTube channel. We are recording this one and we will post it over there. So if you miss any of the event, you can always follow us over there. But the best way to do it is to join us for these live events and be part of this and ask your questions too. As I mentioned, a very active LinkedIn group. You need social media to share information, and that's what we use it for scholarly activity, for events and opportunities that are coming by. You want to probably look at any of the AI healthcare conferences that might be coming up, and you want to be there. So many publications related to AI and healthcare. Every year, we publish our famous AI and healthcare year in review. I'm actually working on that right now with our team. 23,000 or so publications based on our search methodology, being consistent year over year. So 23,000 publications based on that methodology from last year. We're sifting it through. We are working on curating it so that we can provide you what happened with AI and healthcare publications last year. So that will be coming by end of February, just like we do every single year. But in our Learn community, you'll find this curated list of articles. The ones that we're going to talk about are actually available there in our Learn section. We had featured them. So you'll find the links to those publications. We categorize them, as you can see on the slide over here, based on the different healthcare specialties, including now, of course, the large language models too. We have a separate filter for that too. So you can select the healthcare specialty that you want the application for, and you can navigate that. Everybody is looking for data, and of course, open source data sets are increasing. Your one-stop shop is our data section, and you'll find almost 200 links to open source data sets or data warehouses all in one place, all available through filterable option. You don't have to do a Google search. They're all available over there. We provide you with some basic information about there, and you can just click the link and you can go ahead and find more information about it. Of course, they are not available directly through our website, but we provide you the links so that you can go to these open source data sets and do your modeling work or validation work. Podcast is our BrainX Talks, where we feature some of the key researchers, key developers, some visionaries, to listen to their journeys, learn from their experiences, and then also be able to learn from where they see AI and healthcare is going. So it's more about the journey and where they see AI and healthcare is going, and amazing conversations that we have with them, available through all your podcast channels, whether it's Spotify or it's Apple or YouTube. So you can get these. So subscribe it through that. Meetings and conferences, we highlight them over here, specifically the AI and healthcare ones. So if you want to know where you should go, where you can present, a lot of those opportunities are available right through brainxcommunity.org, and you can look at that. Again, our feature publication from last year, as I said, it is all about strategies. It is all about the strategy for application of AI in healthcare, and that's what we published last year, now present on Amazon, so check it out. But one of the most important critical topics, evaluating large language models in healthcare. And I'm so excited because there were 2 publications that came out last year, and the third one which is in preprint from us, which we are working on as a final one right now. But those 2 publications really caught my attention. They were my favorites for the year without any bias. One came from Suhana Bedi and her team from Stanford University. She's currently a PhD student in biomedical data science at Stanford University. And then the other one was from Yanshan Wang about a great analysis and development of a framework. And thank you, Yanshan, for having me part of that work too. That was an amazing work. So we'll talk about those publications. And then Dr. Ashish Atreja, he'll be joining us too, who set up this innovative group or an entity called VALIDAI, so that there can be a cohesive effort towards validating these generative AI models. And it is a unifying platform that he has built. BrainX AI is part of that. And it's amazing that we are all coming together to address these complex issues with large language models and ensuring that they are applied in a safe manner for AI and healthcare. So the publications that I was talking about, they are all over here. You would have seen them on our website too, or on the LinkedIn posts too. But one that was published in Nature, the other one that Suhana had led was published in JAMA, and the other one, the one that is HumanELY, is currently on medRxiv in a preprint, but we are working on the final version for that, and hopefully should be coming out soon. So those are the 3 publications that we're going to be talking about, but we're going to be talking about certain themes about AI evaluation. So when we were working on, that is, my team was working on all these large language models that are out there, and we were trying to figure out, okay, this is great, and they can perform a lot of different tasks, but how do we evaluate them? One of the issues that was challenging for us to see was that the technical metrics, and we're going to talk more about it and get feedback from our other speakers, was that it's hard because different publications were using different metrics, and that's why we ended up creating a tool for ourselves called HumanELY, a framework for ourselves. And we said, why don't we make it open source? Why don't we make it available? So it's available through brainxai.com. But that's the basis for this. The evaluations, we were struggling with, how do we evaluate these large language models? And that's why it's such an important topic. And I think what I found was that it wasn't just us. I think this has been described by the other speakers too. This is the publication that was led by Dr. Wang, where again he's showing that in this particular publication that there are all these different aspects of application for AI in healthcare, especially large language models in healthcare, that are being researched. But again, the question is, how do we apply that? And then this one from Suhana, where again, a little bit complex graphic, but amazing figure, which has so much information in there, talks a little bit more granular in a granular way in terms of the tasks that these are being tested for, that is the large language models. But also, if you note at the bottom, it's also looking at the different dimensions of the metrics for evaluation. So my guess is, I think we were all struggling with the same question, right? So Suhana, I'll start with you because this is a very powerful figure that you and your team made over there. It says a lot. So can you tell us your experience with the evaluation in healthcare of LLMs in healthcare, and what was the, if I'm setting the stage right, was that where you were also struggling, or your team was also struggling?
Yeah, thank you for presenting the figure, but a bit of a backstory there. So I was a trained software engineer and I joined Dr. Shah's group, and I was all set to train yet another large language model in a healthcare application, even though there were off-the-shelf ones available. I thought, well, my main job is to engineer things, so I'll just create yet another model. And that's when Dr. Shah said, but how would you evaluate it? And I said, well, a brief lit search should do it, right? And I spent 1 week just searching through the different evaluation metrics that people use to see whether these LLMs work or not. And that's where I saw that there was no state of the art. It was super messy. And it was so bad that there were literally papers out there testing the same model on the same application, same data set, but along different dimensions and had completely different results. So I think in diagnostic ability, one paper tested GPT-4 saying it's great, it works really well. And then another paper says it underperforms. So that's when I figured that, well, if there is no standard way to evaluate and we're not even on the same page in terms of what works and what doesn't, I think that's a paper in itself and that's something that needs to be looked at. So that's what the figure here represents. We took 519 papers across literature that were using LLMs in a healthcare application, and we focused on the methods section, especially the evaluation section, and broke it down by the metrics they're using, which are on the x-axis, and then the type of tasks they're using it on, which is on the y-axis.
That's great. So, Yanshan, was it the same struggle you were having too? Is that what led to the paper that you had? Let me go to that graphic here. Is that what you were looking at too when you and your team were trying to figure out or go on the quest, I should say?
Yeah, exactly. Because my team has been working on NLP, natural language processing, a long time, and in the traditional natural language processing setup, you usually have a well-defined data set with the training data, validation data set, and testing data set. And then once you train the model, you can validate a model and test the model using the so-called gold standard data set, right? And there are several measurements to evaluate, either it's the text classification or name entity recognition or, any task using like a precision, recall, FMS score, accuracy. Those are all, traditional metrics. But the LLM is a really different approach compared to the traditional NLP because LLM is generating text. And even you use LLM for a lot of, let's say, name entity recognition or text classification task, it will generate, some text that, is different from your labels. Sometimes, is totally different things. So this text generation nature makes the evaluation of LLMs, very difficult and also different from the traditional approach. Of course, we can still use the traditional approach to evaluate LLMs and use those traditional metrics. But one thing is to evaluate the generated text is, accurate, is also safe. It is also has no, fabricated information. And that part, sometimes we call that a qualitative evaluation or human evaluation, is something really new, in the current LM evaluation. And when we try to evaluate our LMs in those healthcare applications, we find that, we actually also, similar to Stanford team, we also did a literature review, and we found there are so many various methods of evaluating these LLMs, with human experts. And also the dimensions also varies across different healthcare applications and domains. So, and then I asked my student, why don't we just, evaluate all the published work and see what kind of application are there and what dimensions people have used to evaluate that and what kind of methodology people use to evaluate that. And that's actually came up, with the Quest framework, which we kind of evaluate all the published LM literature, in the literature, and also come up with our own idea how we, gonna to make sure the evaluation is reproducible, is convincible, and also comprehensive. And that's also the background of this study. So the figure you showed here is the healthcare applications of using LM that published, in the past, I think 2 to 3 years. And as you can see, a lot of applications are used in clinical decision support, in education, examination, patient education, and also medical question answering. And if you go to the next page, I think you have some dimensions showing in our article.
Yeah.
Next slide.
So I think we're gonna get to that in a moment. We just start.
Okay.
We were just at the starting point. We're gonna get to that. So I think we had a common starting point, right? So everybody's very excited to use large language models, but I think we all. I think to me it's like, okay, I think I'm surrounded by the bright minds over here, and they're validating the issue that I was facing. So it's not, I wasn't wrong in understanding this, that evaluation is a challenge, because we are all too excited about just putting them in healthcare, using them, and leveraging this amazing technology to help our patients. But it gave me a pause, right? It gave me a pause because I didn't think we necessarily had the right tools to, or the right ideas to evaluate it. But traditionally, I think Suhana and Yanshan, both of you had touched on this briefly. Traditionally, we have used a lot of technical metrics for rest of the AI in the past. And what I saw initially, and you can correct me if I'm wrong, was people were using some of those traditional technical metrics commonly used for natural language processing, for evaluation of these large language model outputs too. But they, from what we understood and from our trials, we didn't think that they were designed to optimally evaluate the LLM outputs. What's your experience with the technical metrics? Because human evaluation is a completely different beast in many ways. It is very, very challenging. So historically, it's been easier because you can just run the technical evaluation metrics and get the accuracy parameters and then try to validate it. Was that one of the issues that you found, and that's why you also focused on the human evaluation aspects? Suhana, what do you think?
Yeah, I totally agree. And as Dr. Wang said as well, that most of these metrics, which are automated metrics, are optimized for natural language generation tasks. So things like what are the common n-grams over the generated text, or like rouge and blue scores. But these don't work in a healthcare setting because we're not trying to look for an exact match. It's totally possible that your model spits out something that is still correct, helpful, but not exactly the same in terms of words or tokens as the ground truth response you have. But again, we do need some sort of automated evaluation because we can't be bothering doctors to manually annotate these LLM outputs.
Yanshan, what do you think?
Yeah, I think I totally agree. And for the LLMs evaluation, there's some newly generated text that you never see in the, your gold standard data set, right? And sometimes if you use the traditional approach, like a road score or broad score, which basically compute the overlap between the generated text and the, gold standard text data, sometimes it won't work for LM because LM may fabricate some, may hallucinate and generate some misinformation or in the generated text data. And if you just use the traditional approach, you won't be able to capture, how much hallucinate, how much misinformation it generated. So that's actually the limitation of the traditional approach. And also something like completeness, whether LMs consider all the input data when it generates the data is another problem. And also the reference is also a problem. With the LM generated those text data, the traditional NLP approach usually, provide the context or the reference where it used to generate the output, the generated text data. But LLM does not provide. Of course, right now there is some technology like RAG or those framework, but essentially LLM doesn't really provide the reference why, how it's used to generate the text data. And particularly if the generated text data come from the original, data set during pre-training, is very difficult for LLM to generate. So that's why those traditional metrics usually don't work very well to measure all those behaviors from LLM.
Yeah, that's great. And I'm glad Dr. Atreja joined us at the perfect time. So thank you, Ashish, for joining us from UC Davis. And we were just setting the background to this. And I think we were talking about our struggles, struggles that were researched by Suhana, by Yanshan, and by us also, that we didn't find that there was consistency in evaluation of large language model outputs. And one of the amazing things that you led and set up was VALIDAI, with the idea that we need a common team, we need a community, we need some kind of a sandbox where we can play together to be able to assess these large language models or generative AI. So do you want to talk about what was the impetus to set up VALIDAI and how we are approaching that?
Yeah, happy to, and I'm delighted to be here. Apologies for being late. Today's a clinical day. Are you able to hear me okay?
Yeah, we can.
Wonderful. So I think we started seeing with generative AI, I think there's an advent of new science. I don't think so many of us foresaw, at least I did not foresee, the way the AI will evolve from precision-based mathematical AI to actually generating stuff and taking humanistic qualities. We do believe it's not going to evolve humankind, it's going to completely change healthcare and healthcare research. And for this kind of a broad new knowledge that's coming up, we do believe that also needed a collective learning, because the pace is just so much that no one can really conquer it. Now, you can't expect the CEOs of the health system to know all about DeepSeek and others kind of things, right? But that's happening so fast. So I think instead of each of the health systems, I've been the CIO and Chief Digital Health Officer of UC Davis Health. I was frequently pinging the other UC, 6 other UCs, to say, hey, what do we do with this? And then many other health system CIOs were saying, hey, can you help us tap into how to make sense of this? What to evaluate, what to trust, what to bring in, and how to create an impact. And I looked, Piyush, at back in the days when I was I'm still a gastroenterologist practicing 1 day in a week. We have American Gastroenterology Association. We don't try to learn everything in GI or our medical science alone. We go to an association and all the people come there and we share our best practices, and the science is shared and the practice is shared. And that becomes a hub for us to bring back to our patients. So we had very successfully used the same framework for digital medicine. When I was in Mount Sinai, we established a network of evidence-based digital medicine called Node Health. And that created a framework for evaluation in digital medicine. We felt very much the same need, but completely focused in generative AI. So we learn together, we evaluate together, and we make an impact together rather than doing in a silo approach. So VALIDAI has become an amazing community, very much like an association in generative AI space for us to learn and make an impact. And I would just say from an evaluation perspective, where you are right now, we are looking at not only the LLM evaluations from a model perspective, but can we have a whole cycle of evaluation framework, like a system approach to it? Which means, can we have a process engineering and measure that as well? Can we have an outcome impact? So not only measure the LLM, but also measure the impact, how we're going to use generative AI in. So, so we kind of, there's a paper we have published that 80% of variability may not be in the model stage. It may be at the implementation science stage. Who uses it, how we use it, when we use it, for what purpose. If we astray from the path of LLM, we may get completely different results. So I think that holistic approach is, something that we've been working pretty much on strongly.
No, those are some very important, great thoughts. And I think as you talked about the journey, I think I think it's too big. So I think for today's event, we're gonna stick to the evaluation part of that. So I think we all agree that the technical evaluation is very, very challenging. We don't have the right tools necessarily to do that. That's why we focused on the human evaluation. We talked about either we call the dimensions or the metrics. That's what we struggled with too. Just like Suhana said very well, that everybody was using those different things. So that's what we came up with. We call it HumanELY. That is human evaluation of a large language model yield. That's what we ended up creating in early in 2023. We put it out there, as I showed, on medRxiv. And it was with the idea that the LLM response needs to be evaluated. We came up with these 5 key metrics or dimensions, that is relevance, coherence, comparison, coverage, and harm, trying to define them and trying to create submetrics within them for further assessment. That was our approach. But I saw something similar over here with what Suhana had done and mapped out, and something similar to what Yanshan had alluded to earlier, and they had also done. So one of the challenges is not just with the evaluation, but the dimensions and the definitions of those dimensions aspect, right? So while I call it accuracy, what I found was that some of these studies, as we did a systematic review or a scoping review, we found that even the accuracy definition was used variably amongst the different researchers. What was your experience, Suhana? Let's start with you. What was your experience in looking at some of these metrics or dimensions and how they were used? Did you feel that they were used interchangeably and sometimes they were too complex?
Indeed, yeah. So my goal was, when I did start reviewing these 519 publications, to not come up with yet another table of dimensions, because I really wanted to reuse what was in the literature. But because there was no standard definition and people had different ways of calling accuracy, I found, okay, if I need to standardize it or maybe bucket these papers into specific dimensions, I have to come up with my own names. But of course, going forward, we need to standardize these terms. We need to standardize the definitions of what these mean. And we've seen this even in papers where you're asking humans to evaluate relevance of a model output. The inter-rater agreement is pretty low, because relevance to probably a physician is different from relevance to maybe a nurse practitioner. So it's very important to nail down on the key definitions for each of these dimensions, and then the metrics we're using to measure each dimension.
Yanshan, I saw you in your paper, or I should say in our paper, we took a slightly different approach. We did define it, right, based on what was there in the literature. What did you find when you were looking through these different dimensions or metrics and their definitions? Did you find those challenging too?
Yeah, exactly. And some papers, even though they use the same term, let's say completeness, but if you look into the paper, it means very different, right? So I think the understanding similar to some of the medical concepts, or even more challenging like a diagnosis, right? Different human beings may have different understanding of those concepts. So that's why in our framework, we also design several iterations of annotation guideline. So basically, to make sure all the human beings who are in the annotation task have the same understanding of all the dimensions we define. And we think this step is missing in many published works.
Yeah, I think that's very important, because yes, we need to agree on the dimensions of the metrics, but we also do need to agree on how we define them, because if we are defining them differently, then they are not consistent and not the same. But since I'm talking to two eminent computer scientists, what about the non-healthcare world? What are you seeing in the non-healthcare world? But I'm sure they're struggling with the same, right? Or are they having a different approach? Suhana?
Yeah, I personally think it's a lot less difficult there because we have standardized NLP metrics. Of course, when we get to multimodal things like vision language models or integrating things like audio, there you do need some sort of human relevance or human factors that need to be measured out. But in terms of accuracy or like the generic overlap between the gold standard response versus the generated response from the model output, it's less magnified. But when we start evaluating things like safety or whether there are hallucinations, then I think this problem is omnipresent, because be it healthcare, be it law, be it different domains, we're always going to need a way to be able to flag these hallucinations. And we're actively coming up with automated metrics that can to do that.
Yeah, Yanshan, any thoughts on that? Like, what are you seeing what can we learn from non-healthcare world?
I think actually a lot of things we discussed in the healthcare actually initiated from the non-healthcare setting. So for example, distillation, and a lot of people talk about DeepSeek, right? DeepSeek use a lot of distillation and a lot of reinforcement learning techniques, and all those techniques actually originated from non-healthcare work. And but the healthcare domain is quite, unique. So we adopt a lot of the techniques from non-healthcare work, but we have to realize the nature and the realistics of the healthcare. For example, reinforcement learning in the healthcare, we may not have a large amount of data or large amount of human annotated data set for the reinforcement learning, right? So and then, as I said, a lot of things going on in the non-healthcare domain, and we actually, for example, my lab, we have a bi-weekly meeting, and we just read those papers published in arXiv or in those top AI conference to understand what is technology advancement, what is going on in the non-healthcare world, and then how can we leverage some of the new ideas, some innovative methodologies, and apply that in the healthcare domain.
Yeah, I think that's what we do at our lab too with BrainX AI research. We are constantly looking at the different works that are being done over there and trying to see what we can learn from that. But the human values aspect and the domain specialty aspect is a little bit unique with healthcare. And also the training data that goes into large language models and the specialty context of that, I think, makes it challenging. And I found this not just with the general LLMs, but even those that are pre-trained on healthcare data. I think even there, it remains a consistent challenge the same way. I feel that the evaluation metrics and the technical tools that are there, they are hard to use and evaluate. So that takes us to the experimentation aspect. And Ashish, you touched upon this a little bit, and I think Yanshan touched upon this a little bit too. That it might be the context of who's evaluating that becomes important too, and how many samples you're evaluating. what Yanshan, in this one, we saw that there was a variability in the number of samples that were used for human evaluation based on the studies. So even the experiments are different. So even if your measuring tools are consistent, the sampling is different, and that can induce significant differences in the results, right?
Yes, exactly. And there are a lot of actually in academia and in practice, there's no consistent understanding of how many samples are enough to evaluate the LLMs. And here are just our observations from the literature review. And we kind of think, of course, the more the better, but sometimes you have to realize the funding human resource are limited. So basically our suggestion based on the literature review is for each we talk about the information extraction task, and for each concept, if you want to extract, you want to identify or understand based on the clinical notes or clinical text data, you need at least 130 clinical documents to validate the approach, whatever approach you use. And that's basically the meaning score of all the published paper we reviewed.
Yeah, and also I think the same paper touched upon the human evaluators, the number of human evaluators, and we found that challenging too. Like, okay, how many evaluators do you need for this? I mean, some papers we saw there were like just 2 evaluators, and some papers, and I think that's what the distribution over here shows, right? And
Yeah.
some went all the way to 20 evaluators. Any thoughts on, how should we approach this?
Yeah, so most study, as you see here, use 2 annotators, but the issue is they distribute, those different results to these 2 annotators and ask them to annotate those. And sometimes most study do not have the consensus study to evaluate agreement between these 2 annotators on the same set of data set, before distribute all those different data set to them. And our suggestion is, we have to have a annotation guideline development phase that all the evaluators need to annotate the same set of document, and then we calculate an inner annotator agreement, and then we understand whether there is a inconsistency between those annotators understanding the task and also as well as the medical concepts. If it's a clinical decision support, it's more complex because there involve some diagnosis or treatment, procedures. And after every annotator is on the same page and have consistent understanding of the task as well as the medical concepts, then we can distribute different documents to those annotators. And usually we recommend, 2 annotators or more than 2 annotators are enough for a single concept extraction task.
So, Suhana, any thoughts from your side on the what you found, or the number of annotators or the number of samples? How should one approach it?
Yeah, I totally agree with everything that Dr. Wang said. And also, I guess in this case, it's always important to have greater than 1 annotator so you can measure out the inter-rater agreement. But also, I think healthcare tasks are really heterogeneous, right? So for something as broad as clinical decision support, I think you can do a lot of things. You could do simple concept extraction, you could do text classification, or you could do reasoning that models like O1 are exploring. So it's very important to first narrow down the one thing that you're measuring and then develop the right kind of guidelines, and then see whether the annotators you're using have an high inter-annotator agreement on those. Initially, I thought, and I think there's some work in pure CS fields where you just rely on the law of large numbers, where if you just increase the annotators to say approaching infinity, you would get some sort of agreement. But in fields like this, where it's very subjective, it really depends on how and what you're asking them to measure.
Ashish, that was your experience here. So we actually have been running another experiment comparing LLM and LLM RAG technique, and Ashish has been part of that. We hopefully will get it published soon. And he and a few others used HumanELY to do that. What was your experience as an annotator trying to annotate this and the biases that might be there, and how many annotators, or how should that be approached as samples and all?
Yeah.
What are your thoughts from that experiment?
It's a great question, and I think we can leverage the prior other scientific disciplines. I'll take you back to my GI world, IBD world, where we needed a scientific way of measuring the severity when we look in a colon of disease area for ulcerative colitis. We came with so it's been years in development of standardized scoring, but in spite of having standardized scoring, there was so much variability. So for a clinical trial, we had to train a full course, a 2-day course, so humans can actually evaluate after the standardized scoring and do it the right way. And as you may know, many of times we go with at least 3. And the reason is the third becomes a tiebreaker, many cases in that regard. So I would recommend, for many of the scenarios, at least you can always have exceptions, but going at least with 3 or more to allow that kind of Cohen's inter-iterative classification and chance for disambiguation in that regard. I also want to just extend, I may have to drop out. I think as we evaluate, I think Piyush, we wanted to see if some of those basic stuff LLMs can start evaluating, right? And that would be such a fascinating thing, because if we train them the right way, they may have less variability in that regard. And I kind of equate many times healthcare to non-healthcare and be inspired from them. Very much like we used to have, just cars, you can have some kind of a speed control automatic in that regard. Then they moved to Tesla had a little bit more controls for the auto drive part. Then it became right now, I just bought my Tesla, so it's fresh in my eyes for supervised full speed driving, full self-driving. I went to San Fran without driving anything. It's just amazing. And now ultimately it's gonna be unsupervised full self-driving, right? So we may see the same kind of trajectory. Initially, it's mostly human. We may start taking some aspect of LLMs. Then for some things, we'll identify LLMs can do it fine because they can be scaled much more on certain things, and we do more complex things. Then ultimately, we may not even have to supervise some of the mundane stuff. So I think that trajectory is something we can inspire from as well.
Yeah, I know, that's great, and I think I'm going to show that at last. One of our works got accepted at the AAAI conference with that concept, and it's also important, something that we'll be sharing in our upcoming publication about who evaluates it, and that's something that we have been researching too. And as I said, like, we will be sharing, but it's very interesting. As we did that experimentation, again, the publication isn't out there yet, will hopefully be out soon, but we looked at who evaluated these large language models in healthcare. And it turns out that I think our approach, the researchers have leveraged the specialists to do that, which is what you want for a heterogeneous specialty like healthcare, because you have neurosurgeons, you have gastroenterologists like Dr. Atreja, you have anesthesiologists like me. And these are all very specific specialties where everybody's trying to use LLMs. I don't think I have any capability to assess the GI or the gastroenterology specialty queries or contexts, similar to Ashish or me trying to evaluate neurosurgical procedures and their aspects and all. So I think who evaluates also is an important aspect of this. It's the number of evaluations that you do. It's how many evaluators you have. And I think who evaluates is something that we will also address in our future publication over there. And again, this is another graphic that was there from Dr. Wang's study. about number of human evaluators and a number of samples used. It describes this very, very well. So let's go to the frameworks and tools, because I think we defined the problem very well. And it's not to take away all the excitement or spirit, but to bring in that caution that I think when we read all these publications, when we look at all this research work, I think we need to have a baseline understanding of correct way of interpreting it. That is this evaluation what I want to go by or no? Does this require further evaluation before I accept the results of these experimentations? And I think that's where we're trying to build these words of cautions. But I saw this table in Suhana's paper, and this was very exciting because I think for the first or the second or the third time, I would say, but in 2023, this was like a great table which provided a summary of key recommendations for evaluating LLM healthcare, one of the best that I've seen. So Suhana, do you want to tell us and talk to us about it?
Yeah, thank you. Happy to walk you through this. But after we concluded writing the paper, we to ourselves thought, well, that's a mouthful. Like, what are things that people need to remember, or what is the one snapshot summary of things they need to implement while they're evaluating LLM? So first one is to use real patient data if possible. Accessibility is hard, but using platforms like BrainX and there's more open source data that people can leverage. We found that most of the studies were on medical board exams, which are good baselines, but just passing a medical board exam doesn't guarantee that you will be a great doctor, because what a doctor does in an everyday world is, they get a patient case, they have to actively reason what are the next lab tests they have to order. They have to treat the patient, record their lab tests or like their vitals over a period of time before discharging them. So it's a very workflowy style stuff that doctors do. So we don't think that claims of, oh, GPT-4 has 88.8% accuracy on the USMLE, so it's going to replace doctors. That is bogus, and that's not going to happen unless we test them in real clinical workflows. Second,
Thanks, Suhana. I feel safer now. I feel better now.
no, we're obviously, again, we're trying to augment doctors here, not replace them. Second is standardizing the tasks and dimensions of evaluation, which speaks to a lot of stuff we've talked about, right? We need to come up with uniform definitions of what we're evaluating and how we're evaluating it to be able to leverage human evaluations and also in the future LLM as a judge, automated metrics, things like that. Third was this lack of priority on administrative tasks. Now there are AI scribes out there that are being deployed actively, but in literature, everybody was just evaluating these models on clinical decision support, which is great. Again, a super impactful area, but what about all these administrative tasks that end up taking a lot of clinicians' time? They're, spending hours just documenting discharge summaries or patient visit notes and things like that. So there needs to be more work done in evaluating these or exploring these administrative tasks that can be automated. Next is bridging gaps across specialties. Again, we've mentioned how, or Dr. Mathur mentioned how, there's a neurologist, you can't expect them to evaluate something that's out of a GI specialty. So we need to make sure that we're not, enhancing or the gaps that are between different specialties. We found in our review that most of the papers were just looking at like internal medicine style questions, but things like genetic medicine or nuclear medicine unexplored. There was literally one paper. So we need to make sure that the population we're looking at is representative of different specialties, different doctors, nurses, administrators, so that everyone can equally benefit from the power of LLMs. And then last, things like financial impact, biases, we need to make sure that we're recording them in a real, deployment setting. There have been a ton of models that were tossed around in the past, IBM Watson, there was the Google Health retina scanning model, but they all failed in deployment. Why? Because the data was inconsistent. The way we were measuring it was inconsistent. So we're measuring these models in our simulated, siloed lab conditions, but it's time to test them out in the real world and start measuring where do they fail and start iterating and improving upon them. And then, making it an open source community and publicly reporting failure modes so we can all benefit from these and enhance these models in healthcare.
Well, that's great. I think this list of recommendations, as I said, like, is awesome, and hopefully we can take these recommendations from last year, and that's why I put it in January. That's the goal. That let's work on these this year, and that's why we also put the HumanELY framework out there to be able to assess, so that everybody's assessing these consistently, using the same definitions that we have suggested over here. Of course, you can use different ones too, but there should be consistency. It should be comprehensive, just like you mentioned. We have to have it in a measurable way. And one of the aspects of what we are researching that's coming up in hopefully in a publication soon too, is the scaling. The scales are different too. So we wanted like consistent scaling. I think that was there in Suhana, your publication, or Professor Wang's publication that I'd seen too, and so that we can compare these evaluations. Otherwise, just too diverse to be able to do. But also something that you touched about bias, we also found that some of the harm metrics, as suggested in Quest, something that you found, Suhana, we also found that privacy and even toxicity, for example, people are not necessarily measuring them. They're just assuming that if the response is accurate, which is the most commonly measured thing, or inaccurate, then either there is toxicity or not. But we know LLMs can introduce toxicity even by how your prompt or what your prompting style is, and also. Yanshan, what about your thoughts on the Quest frameworks with Suhana's guidance and your team's guidance over here, and the application of Quest framework?
Yeah. So in the Quest framework, as you see here, we have 3 phases. First phase is planning. Second phase is implementation and adjudication. And third phase is scoring and review. And actually, the planning take a lot of time because whether the evaluation itself is trustworthy or not, it really depends on how we define the task and how we make sure the guideline, is accurate and every evaluator is on the same page during the planning. And during the planning, you can see we have the first we have to define the goals, task, and the stakeholders and the success criteria. And in this phase, sometimes when we consider the goals, we have to ask different stakeholders. For example, if your IM application is a patient education tool, then you have to keep the patients, in as a stakeholder, and ask the ideas from them. What are their success criteria? And if your tool is for medical education, you have to have some medical students, in the team to by their perspective, and translate their perspective into some dimensions. And then once we have the team set up, we have the task and also some success criteria, then we can sample some clinical documents, that are generated from the language model. And then after we have this data set, we will develop a standardized evaluation checklist based on our dimensions and also the guideline. The guideline need to be very specific and very, very accurate. So tell the evaluators what are we evaluating and what are the definition for each dimension. And then we choose those, we select those reviewers or evaluators and train the evaluators in an iterative process to make sure, their understanding of the guideline is the same as our own, the investigators' understanding. And all those are, in the planning phase, which actually we are implementing this. We understand, this part could be really time consuming, but it's very necessary to make sure that the evaluation process is accurate. And the next phase is implementation and adjudication. And the implementation and adjudication actually is quite straightforward. So once you have all the annotators, understand the guideline, you just give them, distribute the usually equivalent number of documents, and then ask them to annotate based on the guideline. And then if there is any, contradictory or any kind of inconsistency, sometimes, evaluator may raise some question when they, evaluate some documents. Then we must have a more senior supervisor usually more senior clinician who understand the problem better, and then adjudicate, how we process with those documents with some confusion. And then last is calculate the scoring from the annotation result, and then use some statistical methods to calculate whether there's statistical significance among those annotators, and then use some visualization methods to visualize the results. Because sometimes when we present this back to the clinician, we have to make all the numbers meaningful in a meaningful way. So this is the entire process, and we actually also developed a tool to facilitate this process, because a lot of the work are manual, and instead of just read our paper about those details, we developed a visualization tool to help the team understand those dimensions, understand the process, and follow the process to do the evaluation.
That's great. So I think from where we started last year, exploring, how to evaluate these, at least we have some recommendations, some guidance, some frameworks and tools to be used this year. And I already see there is excitement in the chat about, can we use LLMs as judge? So just hold on that thought for a moment, because we're going to get there in a moment too. But I want to go back to Suhana. You're extending this work, is what I heard, and that's based on Helm. Helm was, you can describe it as the framework that was put out by Stanford previously too for evaluation of LLMs. Where are we going with this?
Yeah, so we feel after our JAMA paper, we wanted to do something actionable. And out of the table that we saw, the main action items were to first start aggregating real patient data on tasks that really matter. So not just answering medical board exam questions, but real tasks like generating a differential diagnosis given a patient record. Or planning treatment, scheduling resources and staff, and again, making it broad or representative enough where we're not only focusing on one specific clinical specialty, but we're focusing on administrators, nurse practitioners, clinicians across being neurologists, nephrologists, whatever. So once we have this broad task categorization framework, we start developing benchmark data sets. And our goal here is to leverage real patient data as much as possible. Now that we have our tasks given, our benchmark data sets given, we're just going to throw these at open source models, and be it open source or proprietary, and see what measure the exact state of AI in healthcare. Again, it's when people say that GPT-4 performing really well on the USMLE means it's going to replace doctors. That's nowhere true. We're nowhere near that. So we need to actively measure as new models like DeepSeek or O1 are being released, are they really living up to the hype? Are they really worth testing in a deployment environment? And we leverage different evaluation metrics. So starting with the standard dimensions that are listed in the paper to different evaluators, right? Deterministic would be our static automated metrics like Blue and Rouge, or something like an LLM as a judge. And human evaluator. So we're leveraging all three axes here: automated metrics, LLM as a judge, and human evaluators for all these tasks and data sets. And then we're seeing, hey, we're putting it up as a leaderboard, and we're hoping to release this sometime in the middle of this year, where we have this active leaderboard of tasks and metrics and model performance. And that paints a picture of the current state of AI in healthcare and how much we need to work on different dimensions.
No, that's great. We're looking forward to it being released and developed so that we have the right tools paired with the right recommendations to go ahead with that. But Maxime in the chat had asked this question about using LLM as judge, because human evaluation scalability becomes a problem. It's a real challenge, and we have been thinking about that too. That you can't keep on doing human evaluation, especially if you need to do it on X number of samples for certain specialist evaluations. I think it becomes a real challenge. So that's a real important question. And that's what we experimented too. Dr. Atreja was part of this. I see Dr. Charu Subramaniam over here in the participants. So she was part of this experimentation that we did using large language model. And we are presenting this poster at AAAI 2025 at the Theory of Mind workshop. We were evaluating the same question, that can LLMs act as a judge for healthcare LLM application? And we found that yes, there's some amount of agreement in certain dimensions, but there isn't in certain other dimensions, and a lot more work needs to go over there. And I think what it represents also is that that the inconsistency that is there sometimes in the prior set definitions, that they were not clear. So I think we couldn't have jumped to LLMs as judge without consistent metrics and definitions to base it on. And my personal feeling is that it has to be somehow has to be a human in loop when we do these as judge. At least for now, Dr. Atreja has a viewpoint that eventually in the future, which I agree with, we will get to autonomous metrics and maybe LLMs or other technical tools to judge it. But Suhana, starting with you, I want to see, where do we see this going in terms of automation?
Yeah, and that's very powerful work. I'll be sure to give this a read. But even before we're able to use these tools, the way Gen AI is different from a predictive AI or the traditional AI is there is a layer called preference alignment. So even before you're able to use ChatGPT, Claude, they are aligning these models to human preferences. And that's being done in the back by these big companies, or even for open source models. So we're already seeing this happen in action. And now that preference alignment is not done by humans completely. It's done by bigger models. So Dr. Wang talked about model distillation. So you have a small model and you have a bigger, say, GPT-like model that is closer to displaying these human metrics or human values. So you're making that big model teach the small model how to align to human values and human preferences. So I think it's just a start, and it's great that we're laying out these frameworks and definitions to promote work in this field of being able to scale our evaluations and human values using LLM as a judge.
Yanshan, your thoughts?
I think technically AM can definitely use as judge in the healthcare applications. The main issue is the acceptance of the community, because healthcare community, they always view gold standard as human evaluated results, right? And even FDA, they want some experimental result or not the LM evaluated result. So it's really the matter of the healthcare administrators, leadership, and also the FDA and all those agencies, federal agencies, how they are acceptable about using LM as a judge to evaluate the results. So I don't see any technical hurdles, but it's really, in the healthcare domain, there are a lot of actually legal concerns that are out of control, of the, it's not really technical issues.
That's great. So I think this was a great talk. Hopefully, we built in better understanding from all the work, amazing work that Suhana and Yanshan, you and your teams have done, along with Raghav Awasthi, who has led this work from our lab. And hopefully it clarifies, provides that clarity, but also provides this inspiration that yes, there are opportunities to do it the right way. And this year, that's, I think, a big focus that we should have, so that we have the right tools, the right parameters to evaluate them before we can implement them, or even if we are implementing them, then we are measuring the impact of implementation in the right way, so that no harm is done to our patients, which is central to the oath that a lot of us physicians that we take over here. So thank you to the speakers. We come to the end of this session. Thank you to the participants. Great thoughts over there and discussion. For the future sessions, please follow us on BrainX Community. Some of the papers that we talked about are already there. The future work will be posted over there. You don't want to miss it. But thank you, everyone. Thank you for being part of this event. Take care.